Good day, everyone. My name is Patti Duncan from Discovery Education, and I want to welcome you to the White House and Discovery Education of the People series. Today, in honor of Space Day, we are coming to you live from NASA's Goddard Space Flight Center in Greenbelt, Maryland. You can join the conversation on Twitter at DiscoveryEd using the hashtag #OfThePeople. So today we have with us the chief scientist of the NASA Goddard Flight Space Center, Dr. Jim Garvin. Dr. Garvin, welcome.
Thanks, Patty.
And we want to really thank you for hosting today.
My pleasure.
We've had a lot of students send in many questions. Actually, we have like thousands of questions. And one of the main things that our students want to know is exactly what is a chief scientist and what is it that you do here at Goddard?
So here at Goddard, we're a science center with engineers, scientists working together. And really my job is to represent this big workforce of scientists that explore the universe, rewrite the questions we're asking as we look at our place in space, where we're going, are we alone? And so that collective of women and men, scientists and engineers working together here at Goddard are exploring our place in space firsthand. And I'm lucky enough to be a part of that team, working with them to make that all possible for all of you.
That sounds like an amazing place to work. We were lucky enough to come here last week and take a tour of the Goddard Space Flight Center. We'd like to show you a little bit of what we saw.
Welcome to the Goddard Space Flight Center. We're here in a special facility where there are more scientists studying the universe, the Earth, space, the sun, surfaces of planets, their interiors, than in any other center at NASA. As NASA's flagship science center here at Goddard, we test and build spacecraft that explore the Earth. We test and study and service the Hubble Space Telescope. We study rainfall on Earth. We explore the surface of Mars with instruments that look for the signs of organics. And we build the giant observatories that will extend our vision back in time with unbelievable clarity, the James Webb Telescope. Here in this very building, we've tested aspects of Hubble, and we're getting ready to finish the testing of humanity's greatest science mission, the James Webb Telescope. And right over here, you can see the giant thermal vacuum chamber, which simulates the vast recesses of space so our spacecraft know what they're in for. So here at Goddard, we have engineers, scientists, managers, all working together on NASA's mission to explore, discover, and understand our place in the universe.
Jim, thank you for that introduction of the Goddard Space Flight Center. It looks amazing. Now, before we go and learn a little bit more about the missions that are happening here, I have a really important question. Didn't you just recently find dinosaur footprints here on campus?
Absolutely. In fact, this is an amazing time. Here at Goddard, one of the first science centers across all of NASA, we have a record of ancient life, just as we're looking for signs of past life on other worlds, in other solar systems perhaps. There is a record of big dinosaurs known as nodosaurs from the Cretaceous 70, 75 million years ago that we've found as we've excavated for new buildings right here at Goddard. So it's a nice connection, a juxtaposition between the history of past life and looking out across the universe in search of signs of life beyond.
That's a really nice blend of astronomy, geology, paleontology, all rolled together.
Right.
So our first question today comes from Christina at Family School 32 in New York. And Christina wants to know, what other jobs could someone have here at NASA if they weren't interested in being an astronaut?
Well, great question, Christina. Thanks. Here at Goddard, for example, we have 9,000 employees. We have everything from scientists, mathematicians, engineers that build telescopes, spacecraft, instruments, to artists, communicators, animators, social media experts, financial analysts that figure out where we send the money to do all this cool stuff. There's really a place for almost anyone to work here at NASA as we explore the universe to find out, really, what's our place in space.
Got a job for me?
We'll take you.
I'd take that in a minute. All right, so I know that we are celebrating Space Day today, but didn't you just recently have another celebration involving your Hubble telescope?
We did. NASA's really proud. This is the 25th anniversary of the flight of the Hubble Space Telescope. Really an engine of science, robots and people working together actually, to explore the cosmos, look at our solar system, look beyond, really humanity's portal into the universe. And so Hubble's done 25 years worth of work. And in fact, we're here designing the successor to Hubble known as the James Webb.
Right, so the James Webb Telescope is going to take over. Hubble is 25 years old, reaching the end of its run, and now you're excited to be bringing the James Webb forward. So Erica from John M. McLeod School in Nova Scotia wants to know more about this replacement telescope, and we were lucky enough to find out some more about the Hubble when we were visiting last week. So let's see what that's all about.
My name is Laura Betts, and I'm one of the science writers who's working on the James Webb Space Telescope. It's not only the largest space telescope that we've ever launched out into space, but it's going to be seeing things so differently than we've ever seen them before. It's going to be diving back deeper into the universe and see light from just after the Big Bang. And I am so fortunate because I get to write about the scientists and engineers that are building this telescope. The James Webb Space Telescope is the successor to Hubble, and how it's different than Hubble is that it's a lot larger than Hubble. So Hubble is about the size of a school bus and is about 350 miles above Earth. Webb's going 1,000,000 miles out into space and is the size of a jet plane. This telescope is so sensitive, it would be able to see the details on a penny from 24 miles away. If you're looking at the James Webb Space Telescope, you can see that there are 18 hexagonal mirrors that form its mirror that's 7 times larger than Hubble's. So each one of these mirrors weighs about 50 pounds. And they're very special because they're made of beryllium, which is actually a toxic substance. And on tops of the mirrors, there's a very fine film of gold, about the amount of a wedding ring size, that was vaporized and spread across the top of the mirror. This is very important for the kind of light that it's studying. And in order for it to open up into space, it opens up like the eaves of a table. The clean room here at Goddard is the world's largest clean room, and it's 1,000 times more sterile than an operating room. And it's important because we're working with very sensitive optics, and there can't be any dust or any particulates on it. In the clean room here, we have all 18 of these mirrors, and we also have all 4 of the science instruments. So the way that it works, the telescope works, is light comes in from the distant universe, hits the primary mirror, bounces off the secondary mirror, and goes into the telescope, and then is split off and bounces around and hits all of the science instruments that are studying it. We're trying to learn about the formations of stars and galaxies. We've learned a lot from Hubble about stars and galaxies at their youth and in high school age, but what we really want to focus on is what's happening in the infant and toddler stages. We're expecting a lot of surprises. Hubble was so amazing because it made us realize that there are so many more questions that we should be asking. And our scientists here say that this telescope is going to create an avalanche of discoveries. So we are going to look back at the formations of stars and galaxies in a way that we haven't been able to. So when stars and galaxies are forming, there's a lot of gas and dust swirling around them. So Hubble took these spectacularly beautiful images, but they're a little bit cloudy around what we need to see. So that's why this telescope is going to be able to see so much more. If you want to follow along and see us building the James Webb Space Telescope, go online to our webpage at nasa.gov James Webb Space Telescope, and you can check out our webcam and see the engineers putting the pieces together.
An avalanche of discoveries? That's very exciting. Mrs. Arnold's class from George J. Mitchell School in New Jersey wants to know when you're expecting to launch the James Webb Telescope.
So, great question. We're working hard industriously here at Goddard and across NASA and with partners abroad to build this telescope to have it ready for launch in the middle to fall of 2018. That's about 3 years. Now, Webb is a really big telescope. It has a lot of careful testing to do the job that you just heard about. And it's going to take at least 3 months to get on station for it to begin deploying itself and getting ready for making these spectacular observations.
So when we were here last week, we learned about a lot of missions that are going on here at Goddard. And one of the projects that we heard about was SAM. Can you tell us what SAM stands for and a little bit more about that project?
Sure. So SAM, which is Sample Analysis at Mars, is one of the keystone experiments on our Mars Science Laboratory Curiosity rover. And Curiosity is a car-sized roving laboratory, an observatory on a planetary surface, crawling across Mars within the Gale crater to basically read the record books about how Mars works, how its past environments worked, through the record of rocks, the Mars atmosphere, and everything. And we're excited that SAM was developed here at Goddard to be this keystone experiment.
When we were here last week, we got to meet with the chief investigator for SAM, Dr. Paul Mahaffey. Let's learn more about this mission.
Do you care if we're the only form of life in the universe or not? Or wouldn't you find it interesting to know that someplace else in our solar system, maybe on the planet that's just a little bit further out from the sun than we are, that life might have once existed? My name's Paul Mahaffey. I'm chief of the Planetary Environments Lab here at NASA Goddard Space Flight Center in Greenbelt, Maryland. Nearly every day on Mars, we're getting data back from the Curiosity rover, which landed more than 2 years ago on Mars. And our part of the experiment, called SAM, Sample Analysis at Mars, sniffs the atmosphere. It's the nose of the rover. We either measure the atmosphere or we sniff gases that come off samples when we heat them up. So every day on Mars, we're taking pictures with the camera, we're exploring the rocks with instruments that are on the arm, and every once in a while, we put sample inside SAM and we carry out these experiments. We look at the data and we try and unravel the mysteries of what Mars was like billions of years ago. The big question that Curiosity is trying to answer: is there life on Mars, or was there life on Mars? We don't know the answer to that yet, but we're sure making big steps in understanding how to go about solving that problem. And one of these steps is understanding, were there lakes on Mars that lasted for long periods of time? Are there chemicals, organic molecules that life makes on Earth that we can find on Mars? Are there chemicals in the atmosphere like methane that we find on Earth that comes from life? We're making big steps in answering all of those questions. So we don't know the answer yet. Is there or was there life on Mars? But we're sure making great progress in getting to that point. The rover moves very slowly. It's about the size of a car. We'd love to have it move as fast as a car does, but it doesn't. So it just moves a few hundred feet every day. Depends on how rocky the terrain is and whether you have a lot of sand or not, but it moves very, very slowly. We really want to understand if there's methane in the atmosphere of Mars or not. Methane on Mars could come from life, so that's really interesting. If we find methane, it means that we're hot on the trail of something. We don't have any final answers yet where the methane came from, but it's really exciting. We have another mystery to solve. We looked and we looked for months and months, and then all of a sudden we detected methane. There was a methane spike in our data that lasted for a few weeks. That was another big moment. While it may seem like understanding more and more about modern and ancient Mars doesn't impact our day-to-day going about what we do on Earth, it's part of our culture, it's part of the things that as a human race we want to understand, we want to learn more about ourselves, more about our place in the universe. I always found chemistry and mathematics very interesting. Those are really excellent things to be familiar with if you're interested in a scientific or technical career. But then once you start exploring the planets, you understand how many different skills you have to bring to the table to do this job right. You require people who are good at programming, you require people who are good at mathematics, you require people who are good at chemistry, you even require people who aren't good at any of those things, but they're good at communicating to other people what this endeavor is all about.
So he makes some really interesting points, especially about developing skill sets. So everyone should remember that, right?
Indeed.
So I've been told that the Curiosity is one of the most complex instruments we've ever landed on another planet. And certainly the mission is, and SAM is something that many students are interested in. As a matter of fact, we've got Jesse, Damien, Navia, and Angel from Cleveland School in Pennsylvania. And they want to know, how long did it take for you to build SAM?
So that's a great question. These instruments are unbelievable. SAM is actually 3 instruments in one. It took us around 6 years to design, build, test, evaluate, calibrate, and make sure it's going to work in deep space to get it to the point where it could go to Mars. And today, 970 odd days of exploring Mars, Sam's working better than ever. It's still exploring. So these things take time, but it's worth it.
Can you tell us a little bit more about how you communicate with Sam and Curiosity?
So Curiosity is on Mars, and today that's on the order of 100 million miles from Earth. So basically, we have a routine. Every day around 10 o'clock local Mars surface time, we communicate through to Earth, either directly or through a relay satellite, in this case, either the Mars Reconnaissance Orbiter or Mars Odyssey. This allows us to send signals up to Mars orbit and back to Earth. Here on Earth, of course, sometimes the clocks align, and so 10 o'clock on Mars is 10 o'clock in the morning in California or in Maryland. But the time of day, the length of day on Mars is a little bit longer than on Earth by about 37 minutes. So as we start working on Mars time, the day extends and extends. So our scientists and engineers that work on Mars may be all working at 10 o'clock one morning, and 3 months later, 3 o'clock in the afternoon, 3 months later, 6 o'clock at night. So we got to get to know Mars on Mars time, which isn't quite like Earth.
Mars time is really interesting. Can you explain just really quickly why Mars time is different than Earth time?
Because Earth rotates in 24 hours. We're very used to that. The ebb and flow, sunset, sunrise. On Mars, that time for Mars to rotate around its rotational axis is just 37 minutes longer. And that little bit of time over months makes a big difference in how you live and work.
So it doesn't line up perfectly.
Not exactly.
So Mars is something that lots of people are interested in, and we've gotten lots of questions from students. And many of them want to know, when will they be able to go to Mars?
So students and everyone, we're on Mars today. It's spectacular. Our robots are exploring the world as if we were there. Somewhat long time delay, but still, it's amazing. We have orbiters there, and so our presence is opening the Martian frontier. Someday, of course, we want to go ourselves, and we want to extend ourselves to being there. And while some of us feel like we're there now, that prospect is really something we can imagine. And in the next 20, 30 years, thanks to programs we have at NASA and our partners in Europe, in Asia, Australia, Canada, that possibility could become real. As we learn from our robots, the Martian frontier could open to possibilities for us going ourselves to become explorers on site on Mars.
Thank you. That's fascinating. So one of the other scientists we got to meet last week was Dr. James Dworkin, who's working on a project called OSIRIS-REx. Sorry. Let's find out more about OSIRIS-REx.
My name is Jason Dworkin. I'm the Chief of Astrochemistry at NASA Goddard. I'm also the project scientist for OSIRIS-REx. OSIRIS-REx is a NASA mission. My name is Jason Dworkin. I'm the Chief of Astrochemistry at NASA Goddard. I'm also the project scientist for OSIRIS-REx. OSIRIS-REx is a NASA mission to go to asteroid Bennu to give us information about the early solar system. So this is asteroid Bennu. The asteroid Bennu is about 5 football fields across, roughly spherical, so 5 football fields in all directions. And the OSIRIS-REx spacecraft is about the size of a car. It takes about 2 years to get the asteroid after launch in 2016. Then we orbit the asteroid for about a year and collect a sample. We can collect up to 3 times if we need to, and then we return to the Earth in 2023. This is a radar map of Bennu. It's a rapid prototype object. We will orbit the asteroid. It's about ½ kilometer across, and on this scale, the spacecraft is about the size of a head of a pin, and we will descend to touch the asteroid. OSIRIS-REx spacecraft has a 3-meter long arm. At the end of it has something like an old car air filter. The spacecraft descends to touch the asteroid on the end of this pogo stick, blows a jet of nitrogen gas that fluidizes the regolith, that is, mixes it up with this gas. It gets trapped in the air filter, collecting at least 60 grams, as much as 2 kilograms of pristine rocks from the asteroid to bring back to Earth. It's important to get a sample from Bennu because this is a primitive object. It records the formation of the solar system, rocks that are older than the Earth that we can bring back and understand the chemistry of the ancient solar system, the origins of life on Earth or perhaps elsewhere in the solar system. The sample we bring back from Bennu will rewrite the textbooks. And when you read these textbooks in the future, you'll be able to ask new questions, look at the sample yourself, and answer them. Maybe someone watching this video will grow up, become a planetary scientist, and study the samples somewhere on Earth, and using the best techniques that have maybe not been invented yet, asking questions we're not smart enough to ask right now about the sample when we bring it back.
Well, one thing I bet that you're wondering about is how we came to name this asteroid, this third of a mile rock that you just heard about. And so we were very lucky to work with the Planetary Society, and a young student from North Carolina, Mike Puzio, was actually the winner in the naming competition for this very important object. So let me just tell you that what's really interesting is he used the fact that the mission, OSIRIS-REx, the way it encounters the asteroid and will sample it, reminded him of drawings of a famous Egyptian god named Bennu. So we're naming the asteroid and our mission to that asteroid for the god from Egyptian mythology that best depicts it.
Because I understand that Bennu had a really long arm, right?
Right.
And so because the project has a really long arm, so
Exactly.
that's where he came up with the name. And he was only 9 years old.
9 years old.
Which is kind of fascinating.
Pretty cool.
Yeah. So why was Bennu even chosen for this mission?
So there are a lot of asteroids, folks. They're almost countably infinite in our solar system. And these small bodies come in lots of shapes and sizes. The trick is to find one you can get to that is in the right place, so our spaceflight engineers can get us there, and also made of the right stuff. So right place, right stuff led to the selection of Bennu. There were only a few choices. And Bennu is about a third of the mile across, as you heard, and it's made of these very primitive building blocks of the early solar system. We don't have samples of that kind of stuff here on Earth. So getting there and sampling it is critical to understanding even the origins of how our planet put itself together to become habitable. And finally, Bennu is of a class of objects in our solar system that are potentially hazardous. If their orbits are perturbed, as happens over long time scales of millions of years, they can be perturbed into things that could collide with the Earth.
But not tomorrow.
Not tomorrow. We got plenty of time. It's all good.
That's good. So people are fascinated with asteroids. And as a matter of fact, we have a student named Sophie who's from Switzerland Point Middle School in Florida. And Sophie is very interested in asteroids and would like to know, when do you think, or will it be possible to land on an asteroid?
Well, great question. Well, first, of course, OSIRIS-REx will give us practice with a robot encountering one of these objects. And these objects are small. A few football fields across, a couple of hockey rinks, if you like that scale. And they're so small they don't have a lot of mass, and thus they don't have a lot of gravitational attractive energy to actually allow them to feel as if you were landing. In fact, when we encounter these objects, we would essentially be docking with them. And you would have to, in fact, be tethered if you went to one yourself. Otherwise, if you took a step off the asteroid, you would, in fact, escape. So today, we're going to the asteroid with robots. We would love to have an opportunity in the 20s, 10, 15, 20 years from now, to send human beings either close to asteroids, close to pieces of asteroids that have been returned and relocated closer to Earth, so we can better get to know this important class of object.
So essentially what you're saying is the asteroid doesn't have enough stuff to hold on to us.
Right.
Okay. So here's another question for you. I've noticed in a lot of the video clips and some of the things you've mentioned that a lot of the measurements that you're taking and talking about are in the metric system. Can you explain why you use the metric system?
Well, great question. In fact, the language we speak in engineering, math, and science that allows us to communicate internationally across all kinds of people, women and men, to build these missions to explore this universe is the language of the metric system. It's a common language, and we need it for our measurements, so we all build to the same standards and these things all work. And so it's very important that we communicate in ways that we all understand, even with other communication barriers.
So even if I can't understand what you're saying to me, I can understand your math.
Exactly.
Okay, that makes sense. So another project that we've gotten a lot of questions about, and I think you can imagine why, is the New Horizons project. So can you tell us a little bit about New Horizons?
So New Horizons is an unbelievable mission of discovery to go to the farthest reaches of the known solar system. New Horizons will go to the Pluto system, about 40 times as far from the sun as the Earth is. So this is way out, and it's been traveling for 9 years just to get close to Pluto. So it's a mission of discovery to chronicle, to inventory a part of the solar system we really don't understand very well.
So students are fascinated. They're fascinated with Pluto. They're fascinated with the far reaches of our, planetary system. In fact, we've got a 3rd grade class at Peters K3 Elementary in California, and same question from Skylar and Ava from Moffett Elementary, also in California, and they all want to know, what do we expect to see when New Horizons reaches Pluto? What do we expect to get back from there?
So when we get to Pluto, that's July, this summer, 2015, we really have only guesstimates of what we'll see. It's going to be spectacular. In fact, our imagination probably does not prepare us adequately for the new science questions that we will uncover as we image and explore the chemistry, the materials around Pluto and its moons. So we're in total discovery mode as we get to this new class of object, so far out that our telescopes only produce a few pixels, a few picture elements across them as we look at them today.
Right, and you called it a new class of object, and that brings up a question that we get a lot, and that is, why was Pluto changed to a dwarf planet?
So astronomers, astrophysicists classify things on the basis of their size, their position, how they orbit our planet's, our parent star, the sun. And so after lots of years of thought, it goes back literally decades, the astronomers feel that there is a class of objects that orbit the sun that are small, but not as big as the primary planets in our solar system, the 8 biggies, Mercury, Venus, Earth, Mars, Jupiter, etc. And so they've classified them as dwarf planets. They're just a little smaller, and there's more than just one of those, Pluto being the first one named. In fact, we have one we're exploring right now known as Ceres. It's a dwarf planet in the asteroid belt between Mars and Jupiter. Fascinating object. Our Dawn mission is exploring it as we speak.
So Pluto's not alone?
Not alone. She's happy.
That's good to know. I know I, for one, am very anxious to see what we see in July and find out more about the dwarf planet Pluto. So, Jim, we have time for one more question. And when I tell you we got thousands of questions, we really did. But there were many questions along this topic. And so I have to ask you, what does food taste like in space?
Well, first, full disclosure, I have not flown in space. Instruments that I've worked with have. But my friends that have flown, including colleagues that have fixed Hubble 3 times, one of the first women in space, they basically tell me that food in space tastes a lot like camping food. So if you like camping and you want to go to space, that's the food sensory experience you'd have. And perhaps we could say probably tastes a lot like chicken.
Okay. So if you happen to be camping and you're eating chicken, you can imagine that you are an astronaut in space and that's what your food will taste like. Well, thank you, Dr. Garvin, for visiting with us today. Thank you so much for sharing all of your great information. We also want to thank the NASA engineers and scientists who've shared their projects with us today. It was fascinating information. You can keep track of the missions that are going on here at Goddard and in NASA in general at their website, nasa.gov. And you can also see an archive of this event at discoveryeducation.com/Space Day. Before we go, I have one more thing to bring up, Jim, and that is, it is Goddard's birthday. So here's a little cupcake for you, and we want to say happy birthday. If you don't know, Goddard was established on May 1st, 1959. So happy birthday, Goddard. Thank you so much for joining us today. We hope that you enjoyed what we talked about, and go celebrate Space Day.
Thank you, Patty, very much.
You're welcome.